So many units, so little time. Okay, so today we're having a short little chat about units and how to convert units. To really have a good time with this video, you will need to understand how to round off and how to write scientific notation. I have already made this video, so please go check them out. I have put the link in the description below. So again, remember to start a like cycle with the like button, and remember the cycle starts with you. Subscribe to this channel, hit the bell notification icon if you want to get notified whenever I upload. Follow me on social media. I'm on Instagram, Facebook and Twitter. Look for NVScienceSlides, and then remember to share this video with your classmates, because come on man, don't be stingy with the information, especially when it's this good. Okay, so now let's talk units. We are talking about units. So the first question you will have to ask is, what are units? And units are essentially a measure of a physical quantity. And your next question will be, what is a physical quantity? A physical quantity are things such as time, temperature, distance, mass, and volume. These are physical quantities, and they can be measured with different unit systems. And what are the unit systems that are available out there? We have SI units, c.g.s units, imperial units, and of course we have natural units. SI units are the world favorites. They are the most agreed upon units, so they are used, well, basically internationally, and I will be discussing them in a bit more detail a little later in the video. c.g.s units, it's all in the name. The C for length is in centimeters, the G is for mass, it's in grams, and the S is for time in seconds. And basically that is how it got its name, c.g.s units. And then we have imperial units, which are mostly used in the United States of America, but I'm sure they're also used somewhere else in the world as well. Here they have pounds for mass, they have miles for distance, they have gallons for volumes, they have degrees Fahrenheit for temperature. You will also need to know the symbols for these units, since some of them are not as straightforward as they seem. Like the symbol for pounds is LB, and it's not a P as you might expect. Okay, so moving on to the next unit, we have natural units. These are used mostly in like deep physics, like physicists, astronomers, they make use of these kind of units. They are super complicated. I had a look at them and they are super complicated. Unless you're a physicist, then I guess these units are just a whole bunch of fun for you. So still measuring length, still measuring mass, time and temperature, but if you look at this table here, you will see that it's just, oh my god, it's so complicated. But I have converted them for you into SI units, that you can see what they look like in SI units, which will be in meters, you know, stuff that you are more familiar with. Okay, now let's discuss the physical quantities, and we will start with
time. Wait for no man.
Yes, Zakes, time waits for no man. I made a little timetable here for you. As you can see, it's a table of time, a timetable, right? Okay, so time can be measured in seconds, minutes, hours, days, weeks, months, and years. Okay, those are the units for time. And notice that with seconds, I said seconds, I didn't say milliseconds, and I didn't say, I don't know, kiloseconds, because seconds is the actual unit. So I will explain to you a bit later what that is all about. So now let's break down the super complicated looking table for you so you can see how to read it. Let's say, for example, in a year. In 1 year, we know that we have 12 months, 52 weeks, 365 days, 8,760 hours, 525,600 minutes, and 3,154 times 10 to the 7 seconds, which is basically just a lot of seconds. That's like hundreds of millions of seconds. All right, and that is basically how you read this table. And then of course I would like for you to start commenting thank you in the comment section below, because this table right here is absolutely amazing. For the most part, you can focus on degrees Celsius, degrees Fahrenheit and Kelvin, because that is what you'll be working with the most. But there also exist degrees Rankine and degrees Reaumur. I don't know how to say that, Reaumur, but as you can see the spelling right there. So now let's take the example with degrees Celsius and let's move it to degrees Fahrenheit. So you would take your temperature in degrees Celsius, you would multiply it by 8 and add 32 to it in order to get it into degrees Fahrenheit. So if you wanted your degrees Celsius to be expressed in Kelvin, you would add 273,15 to your temperature in degrees Celsius. And if you wanted to express it in degrees Rankins, you would take your temperature in degrees Celsius, you would add 273,15 and then multiply by 1,8 in order to get your degrees from degrees Celsius to degrees Rankins. Okay, and then finally, if you want to take your degrees Celsius to degrees Reaumur, you multiply your degrees Celsius by 0,8 and that is how you get them to degrees Reaumur. And then of course the rest of the table shows you how to move from degrees Fahrenheit to the rest of the other degrees, and then as well from Kelvins, Rankins and Reaumurs. So again, you can comment, thank you. Then taking a look at the other physical quantities, let's start with length. How far something is, we are measuring a distance here, and we can measure it in meters, yards, feet, inches, miles and light years. And then when you have a mass, which is a measure of how heavy something is, because that is a weight, you can measure it in tons, grams, pounds and ounces. And when you have a volume, when you are checking how much space you have, you can measure that in a pint, a fluid ounce, a liter, a gallon. And then finally we have cubic distance. Now what do I mean by cubic distance? Basically you can have cubic meters, cubic yards, cubic feet, cubic inches, cubic centimeters. It's basically a cube of a distance, and that is how you will always see them expressed as well. Now let's start talking about SI units in a bit more detail. So SI units basically uses meters for length, and the symbol for meters is a small letter M. Mass, they use kilograms, and the symbol is kg. For time, they use seconds, and the symbol is a small letter S, and it carries on with electrical currents, temperature, the amount of a substance, and the luminous intensity. It is very important that you familiarize yourself with SI units, since they are the most internationally agreed upon units, and usually you'll get asked questions and they will ask you to express it in SI units. So you know, if you're working with distance, you will have to express that in meters. Now let's start looking at the prefixes. Now these are the set of words that appear before the units in order to explain basically what size this unit is. Now this is a very big table. You won't necessarily be using the entire thing, but I did want you to have it in your life as a form of reference. Part of the table that you'll be using a lot is from giga and nano. So it's there from the exponent 9 and exponent minus 9. So giga is exponent 9 and nano is exponent minus 9. Mega is exponent 6 and micro is exponent minus 6. So you see how that works there. So this table is very, very great to have so that you know how to convert between the units. Here I have prepared another table for you with the prefixes, their symbols and their multiplication factor, and I just wanted to show you what those numbers actually look like in case you are not so comfortable with exponents and the scientific notation. To look at it more simply, if you count the number of zeros behind the 1, you can see that there are 9 zeros, and that is how you get the 10 to the exponent 9. And if you're looking at the nanometers, you can see that there are 9 zeros before the 1, so that is how there you get the negative 9. So now let's look into unit conversion. The first thing you will notice here is that the real unit is actually the meter. Everything else is actually making use of prefixes. So we have the kilometer, we have the meter, we have the centimeter, and we have the millimeter. Now all of these are related by a multiplication factor that I have included in the previous slides. So you can pause the video at those points in order to have a look at it. So from kilometer to a meter is a factor of 1,000. From meter to centimeter is a factor of 100. And from centimeter to millimeter is a factor of 10. That is to say, 10 millimeters will make a centimeter, 100 centimeters will make a meter, and then 1,000 meters will make a kilometer. And that is basically what the slide here is telling you. So now let's have a look at some examples of the use of these prefixes. So say for instance you have 40,000 meters. That can also be written as 40 kilometers. And if you have 0,001 grams, that you can write in two ways. You can either write it as 10 to the negative 3 grams, or you can write it as 1 milligram. If you have 2,5 times 10 to the exponent 6 newtons, that can be written as 2,5 meganewtons. If you have 250,000 amperes, you can write that as 250,000 kiloamperes, or you can write it as 0,250 mega amperes. If you have a long number such as this, we have 0,000000075 seconds, that can actually be written as 75 nanoseconds. If you have 3 times 10 to the exponent minus 7 moles, that can be rewritten as 0,3 times 10 to the negative 6 moles, which is also the same as 0,3 micromoles. And that, of course, is the end of our video on units and unit conversions. I will catch you in the next video where I will be teaching you how to change the subject of the formula. So until then, make sure to like this video, share this information, subscribe to this channel, and I will catch you in the next one. Thank you for watching.